Good afternoon. Last class continuation, ma? Yes. Question number 10. A is equal to R minus Z3. B is equal to R minus Z1. F A to B defined by f of x equal to x minus 2 by x minus 3. Is it 1, 1 and onto? So we have to verify the function is 1, 1 and onto or not. Okay. So the given function is a is equal to, so f is defined from set A to set B, where a is r minus set 3, b is set b is r minus set 1. The function is defined like this. F of x equal to like this. First we go for 1, 1. What is the process of 1, 1? Let for every same process, no? For every x1 comma x2 belongs to capital A. Okay, in domain, I'm selecting x1 comma x2. If f of x1 equal to f of x2. Now, if x1 equal to x2, then we can say f is 1, 1. Otherwise, it is not 1. Okay, first, f of x1 equal to f of x2. What is f of x1? From given function, x1 minus 2 by x1 minus 3 is equal to f of x2, x2 minus 2 by x2 minus. Okay. Simplify. x1 minus 2 into x2 minus 3 is equal to x2 minus 2 into x1 minus 3. Okay. Simplification, x1 into x2, x1, x2 minus 3, x1 minus 2, x2 plus minus 2 into minus 3 plus 6. So right side also, x2 into x1, or we can write x1, x2 minus 3, x2 minus 2, x1 plus 6. So here 6 is cancelled, x1, x2, x1, x2, 8 cancel. Next, so take x1 terms one side, x2 terms other side. Minus 3x1 plus 2x1 equal to minus 3x2 plus 2x2. Minus 3x1 plus 2x1 minus x1 equal to right side minus x2. So what is the conclusion now? x1 equal to x2. So first of all we have taken f of x1 equal to f of x2. Now we prove x1 equal to x2. Therefore f is 1. Onto. So we know the process of finding onto. For every y belongs to codomain. What is codomain here? For every y belongs to codomain, if possible, I am taking f of x equal to y. Now we have to calculate x value. If the x value belongs to the domain, then we can say the function is onto. Otherwise, it is not onto. Okay. So many problems we did now. F of x. What is f of x? X minus 2 by x minus 3, which is equal to y. Try to separate x value. No? X minus 2 equal to x1 minus 3y. X minus 2 equal to x minus 3 into y, that is xy minus 3y. So take x terms one side. No? X minus xy equal to, take into right side, 2 minus 3y. Next, take x comma 1 minus y equal to 2 minus 3y. X equal to 2 minus 3y by 1 minus y. It is must be in domain. Compulsory, it is there in domain. What is domain? Only because. Try to understand. So, what is y? Y belongs to B. What is B, ma? It is a real number set except -1. Okay. So Y value cannot be -1 except -1. All real numbers we can select. So then 3y is also real number. Minus 3y is also real number. 2 minus 3y is also real number. 1 minus y is also real number. Real number by real number is also real number except denominator 0. But denominator cannot be 0 now, because 1 minus y cannot be 0, because when it is 0, if y value is 1, but we cannot take y value as 1. That's why it is a real number. So whatever it may be, it is a real number. So it is there in R. A. What is the amount? R minus set 3. That is also real number set only. So it is belongs to A. So what is the conclusion? For every y belongs to codomain, there exists x belongs to domain such that f of x equal to y. Therefore, f is R. So if you want, you can write again definition also. For every y belongs to codomain, there exists, this is symbol one, there exists symbol, there exists x belongs to domain such that f of x equal to y. Therefore, f is onto. F is 1, 1, f is onto. Therefore, f is a bijective function. Clear now? Next, question number 12. F R to R is a function defined by f of x equal to x to the power of 4. We have to check x is either 1, 1 or onto or both. So we have to verify it is 1, 1 and onto or not. Okay. 12th question. Options are given, no need to write options because just we have to find it is 1, 1 or not. It is onto or not. Okay. 1, 1. You can say clearly it is not 1, 1. Why? If we take 1, what will happen? F of 1 value 1 power 4, 1. If I take -1, -1 power 4 is also 1. What is the meaning? F of 1 value 1, f of -1 value is also 1. Means for two different values there is same image, so it is not 1, 1. So, for 1, -1 belongs to R. Here R is domain. In the domain, f of 1. What is f of 1 now? 1 power 4, that is 1. F of -1. -1 to the power of 4. That is also 1. What is the conclusion? F of 1 is equal to f of -1. But 1 not equal to -1. How it is? F of x1 equal to f of x2, but x1 not equal to x2. So it is not 1, 1. Therefore, f is not 1, 1. Next, go for onto. So we know the process now. For every y belongs to codomain, here codomain is also same as domain. That's why I am mentioning for every y belongs to codomain, if possible, f of x equal to y. If possible, f of x equal to y. Now we will calculate x value. That x value belongs to domain, then we can say it is onto. Otherwise, it is not onto. Okay. What is f of x now? X to the power of 4, which is equal to y. So, what is x now? 4 power 4 changes to y power 1 by 4. Or we can write like this: x equal to 4th root of y. Is it belongs to domain or not now? It is not a real number. Why? Why it is not a real number? Because, select example, I am taking y equal to -1. Okay, or y equal to -2. Okay, now it is there in the real number set. -2 is there. So what about x now? X equal to 4th root of 1. That is 4th root of -2. It is not a real number. It is not a real number. That's why it is not onto. What is the meaning? Actual meaning. There is a element in codomain. There is a element -2 in codomain, which has no preimage in domain, which has no preimage in domain, or which is not image of any element like this. Here -2 is there. Here whatever it may be, it cannot be mapped with -2. Okay, no element maps with -2. That's why it is not onto. Okay, now F is not onto. Clearly, F is neither 1 not. Next. Question number 12. F R2 R defined by f of x equal to 3x. F of x equal to 3x. Here also we have to verify, is it 1 1 or onto, or 1 1 and onto. So we have to check it is 1 1 and onto or not. Okay, it is very simple. No? Clearly it is both 1 1 and onto. I will explain why it is 1 1, why it is onto. First 1 1. Let's see. For every x1 comma x2 belongs to R. What is R here now? Domain. Both are same is there now. That's why I am mentioning now. In x1 x2 belongs to R. R is domain. If possible, f of x1 equal to f of x2. Okay, f of x1 equal to f of x2. What is f of x1 now? 3x1. F of x2 3x2. By simplifying, we get x1 equal to x2. So f of x1 equal to f of x2 implies x1 equal to x2. Therefore, f is clearly it is 1 1. F is 1. Go for onto. So we know the process. It is very simple. For every y belongs to R. What is R here now? Codomain. For every y belongs to codomain, if possible, f of x equal to y. Now we should calculate x value. That x value belongs to domain, then we can say f is onto. Otherwise, it is not onto. So what is f of x now? X is equal to y. What is x now? Y by 3. Is it belongs to R or not? Domain. Yes, it is there. Because what is y? Y is a real number. Y by 3 is also real number. So y is real number. Y by 3 is also real number. So x equal to y by 3 is a real number. So for every y belongs to codomain, there exists x belongs to domain such that f of x equal to y. Therefore, it is onto. Okay. So we can write conclusion again. Therefore, for every y belongs to codomain. Okay. Codomain. For every y belongs to codomain, simply we can write R also. No? There exists x belongs to domain such that f of x equal to y. Therefore, f is on. Right on the sun. F is 1 1, f is onto. So f is both 1 1 and onto. Therefore, it is a bijective function. Okay? Question number 9. Right on the sun. F n to n, natural number set to natural number set, be defined by f of n is equal to n plus 1 by 2 if n is odd n by 2 if n is even. For all n belongs to capital N, state whether the function f is bijective. State whether the function f is bijective. Justify your answer. This is the question. Try to understand. This is a simple question. So, f is a function defined from natural number set to natural number set. So, it is defined like this: f of x equal to f of n in terms of n is given. It's split into two parts. N plus 1 by 2 if n is odd. N by 2 if n is even. The function is defined like this. Now we have to verify, is it bijection or not? Okay? We have to verify the function is bijective or not. So bijective means what? It should be both 1 1 and on. Okay? No. For actually, we know that it is not 1 1 function, so it is not bijective. We will explain now. See, for 1 comma 2 belongs to n. 1 comma 2 belongs to n. So find f of 1 domain. In the domain, so n is natural number set. Natural numbers means 1 and 2 also there. So f of 1. So which one we have to take a function? This one or this one? This one. Because if n is odd, we have to take this one. F of 1, n plus 1 by 2. So in place of n, what is there now? 1 plus 1 divided by 2. 2 by 2. Answer is 1. Correct. Next, take f of 2. What is 2? Even. If n is even, we have to take f of n as n by 2. Correct. What is n? 2 by 2. Answer is 1. Try to understand. Here, f of 1. 1 is odd. If n is odd, then we have to take function as n plus 1 by 2. Put n value 1. 1 plus 1 by 2. Answer is 1. Next, I am taking f of 2. 2 is even. If n is even, what is the function value? N by 2. So that is 2 by 2. Answer is also 1. What is the conclusion? F of 1 is equal to f of 2. But 1 not equal to 2. Therefore, f is not 1 1. If f is not 1 1, no need to check about onto more, because if it is 1 1, then only we have to check onto more, because 1 1 and onto, then only the function is bijection. So clearly, first one is failed. So no need to check second one. Therefore, f is not bijective function. F is not bijective. What is the question? Is it bijective or not? Justify your answer. So it is not bijective because it is not 1 1. Clear? Example 10. Show that the function f n to n. So that the function f n to n given by f of 1 equal to f of 2 equal to 1 and f of x equal to x minus 1 for all x greater than 2 is onto but not 1 is onto but not 1. See, very simple question. So a function is given f and 2n. The function is defined from natural number set to natural number set. It is defined like this: f of 1 value, f of 2 value, 1, but f of x equal to x minus 1 for all x is greater than 2. They define like this. Try to understand. You have to prove it is 1 1, but okay, it is not 1 1, but on. So I will explain by diagram, then we will do problem. So what are natural numbers? 1, 2, 3, 4, 5, 6, so on. Here also natural numbers 1, 2, 3, 4, 5, 6, so on. Clearly, f of 1 equal to 1. So 1 maps with 1. Next, f of 2 equal to 1. 2 is also maps with 1. Clearly, it is not 1 1. Why? For two different elements, there is same image. Correct? Na? Clearly, we can say f is not 1 1. No need to check other values now. Simply, first two elements maps with single element 1. For two different elements, there is same image. So, it is not 1 1. Okay? Next. 1 1. Okay, 1 1. Given, already clearly given, f of 1 equal to 1, f of 2 is equal to 1. This implies f of 1 equal to f of 2, but 1 not equal to, correct? F of 1 equal to f of 2. F of x1 equal to f of x2, but x1 not equal to x2. Therefore, f is not 1 1. Okay, it is clear. First part is clear. Next, for onto, we will check. Okay, f of 1 value 1, f of 2 value 1. What about f of 3 value 1? F of 3 value 3 minus 1. That is 2. Correct? 3 maps with, take x value 4. F of 4, 4 minus 1, 3. F of 5, 4. F of 6, 5. F of 7, 6. So clearly it is onto only. Why it is onto? What is codomain? Natural number set. Range is also natural number set. So codomain equal to range. That's why it is onto. Okay. By observation, we can say while doing problem, we have to follow the process. Like this. Onto. For every y belongs to n, that y is greater than or equal to 2. So, because already 1 maps with 1 and 2. Correct? 1 maps with 1 and 2. So, 1 is image. No need to check about 1. So, we are going to check the numbers in codomain which are images of any element. So, we will check. So, y belongs to n, y is greater than or equal to 2. If possible, f of x equal to y. What is f of x? X minus 1 equal to y. What is x? Y plus 1. Is it belongs to domain or not? As it is a natural number only. Correct? What is y? Natural number. It is from 2 only. So y value is 2. Then what is y plus 1 value? 3 only. 3 is also natural number. So for every y belongs to natural number, y plus 1 is also natural number. So what is the conclusion? For every y belongs to codomain, there exists x belongs to domain such that f of x equal to y. Therefore, f is on. Diagrammatically, we can explain like this, but problematically, we have to write the process. Okay. What is the conclusion? For every y belongs to domain. Simply write for every y belongs to domain, there exists x belongs to domain such that f of x equal to y. Therefore, f is, if you want, we can write it here. One is image of 1 and 2. So we are going to check about other elements. So other elements are 2, 3, 4, 5 like this. No? For every natural number which is more than or equal to 2, it's codomain. Okay, for every y belongs to codomain, there exists compulsory x equal to y plus 1. Okay. What is the conclusion? Clearly, f is not 1, 1, but 1, 2. Okay. For example 11, already we did this type of problem. Show that the function f r to r defined as f of x equal to x square is neither on 1. Now already we did question number 2. So same question given in example also. We will do again. See, what is the question? Function defined from real number set to real number set. It is defined as this. F of x equal to x square. Now we have to prove it is not 1, 1, not on. Means neither 1, 1, not on. First, 1, 1. So already we know that f of 1 value 1, f of minus 1 value is also 1. Correct? Clearly. 1 comma 1 belongs to 1 comma minus 1. 1 comma minus 1 belongs to R domain. F of 1, 1 square, that is 1. F of minus 1, minus 1 square, that is also 1. This is the conclusion. F of 1 equal to f of minus 1, but 1 not equal to minus 1. How it is known? F of x1 equal to f of x2, but x1 not equal to x2. Therefore, f is not 1, 1. You can take other example also. You can take 2 minus 2. F of 2 value 2 square, that is 4. F of minus 2 square, also 4. So f of 2 equal to f of minus 2, but 2 not equal to minus 2. You can explain by taking other example also. No? Not compulsory 1 minus 1. You can take 2 minus 2, 3 minus 3, 4 minus 4 like this. So what is the actual meaning of this one? No? F of 1 value 1, f of minus 1 value 1 means for two different elements there is same image. So it is not 1, 1. What is the basic definition of 1, 1? For different elements of A has different images in B. But here two different elements are there in domain, but same image is there in codomain. Therefore, it is not 1, 1. Okay? Next, go for on. Use general method for every y belongs to R. What is R here? Codomain. If possible, f of x equal to f of x equal to what is f of x? X square equal to 1. So x equal to root of 1. Is it real number or not? No, it is not there in domain. Why? Root y is not real number for y belongs to R. I will give one example. minus 1 belongs to R, y equal to minus 1. So what is x1? Root of minus y. Right? So root of minus 1. It is not a real number. Just for your confirmation. What is the meaning of this one? No? There is a number in codomain. There is an element in codomain which is not image of any element. Correct now? Therefore, the is not on 2. What is the conclusion? The is neither 1, 1, not on 2. Okay? in exercise first question is there. Show that the function. Show that the function f r star to r star to r star defined by f of x equal to 1 by x. 1 by x is 1 onto is 1 and onto here r star is non-zero real numbers, means like this, r minus z0. Okay. Is the result true? Continuation. Is the result true if the domain replaced by domain r star is replaced by capital N with codomain being same as r star. This is the question. I'll explain. First of all, what is the function? F is a function defined from r star to r star. You know that here r star is a real number set except 0, means non-zero real number set is denoted by r star. Symbolically, we can write like this only. So you mentioned clearly r star is nothing but r minus z0, means non-zero real numbers. R star is a set of all real numbers except 0. Now, function, how they define? F of x equal to 1 by x. Now we have to prove this is function. This function is there. This function is both 1 and r2. First part, no? Second part we will discuss again. First part we will prove. 1 for every x1 comma x2 belongs to r star. Here domain r star is domain. If possible, f of x1 equal to f of x2. What is f of x1? 1 by x1. F of x2 value 1 by x2. Here x1, x2 are non-zero real numbers, so it is possible. 1 by x1 possible, 1 by x2 also possible. By simplifying, by cross multiplication, we can write x2 equal to x1, or simply you can write x1 equal to x2. Therefore, f is 1 by. Correct? Go for on. For every y belongs to r star. Here r star is domain. Why we are mentioning one? Because domain, codomain both are same now. That's why we are mentioning. If different are there, no need to mention. Na? Okay. For every y belongs to codomain, I am selecting like this. If possible, f of x equal to y. What is f of x? 1 by x equal to y. So 1 by y equal to x, or x equal to 1 by y. Is it belongs to domain or not? Yes, it is belongs to domain. Why? Try to understand now. What is y now? Y is a non-zero real number. A non-zero real number is 1 divided by a non-zero real number is again a non-zero real number. Correct now? Say, for example, I am taking y value as 3. What is 1 by y? What is 1 by 3? It is also real number. Non-zero real number. It is also non-zero number. So, if a non-zero real number is divided by 1, okay, now 1 divided by non-zero real number is also non-zero real number only. So it is belongs to R star. What is the meaning? For every y belongs to codomain, there exists x belongs to domain such that f of x equal to y. Just we are checking now. First of all, if possible, f of x equal to y. Now I am trying to find x value. Yes, we calculated x value. It is also there in domain. That's why we can conclude that for every y belongs to codomain. For every y belongs to codomain. I'm trying to write definition of onto now. So using this, for every y belongs to codomain, there exists x belongs to domain such that f of x equal to y. Therefore, f is on. So both f is 1 and on. Okay, it is clear now. So second part is there in that. What is the second part now? Try to understand second part now. Is the result true? Okay, happy you clear now? Second one. Is the result is true if domain is replaced, domain r star is replaced by n. So f is defined from natural numbers to what is this? Codomain r star. Na? So keep as it is, r star as it is. So codomain being as r star. So the function is same, f of x equal to 1 by x. Now we have to check it is both 1 and onto or not. So f r star to r star defined by f of x equal to f of 1 by x already we proved. It is both 1 and onto. Now we have to replace domain r star with n natural number set. Now the result is same or changes. We have to check. Yes, first 1 for every x1 comma x2 belongs to n. No need to mention domain because both are different now. So no need to mention. For every x1 comma x2 belongs to n, if possible, f of x1 equal to f of x2. What is f of x1 from definition? 1 by x1. So f of x2 value 1 by x2. After simplification, cross multiplication, x2 equal to x1. Or we can write x1 equal to x2. Therefore, f is 1. So before problem only 1, this problem is also 1. By replacing domain r star with n, there is no change in 1. So go for onto. Is it same as first problem or not? We will check. Onto. For every y belongs to capital R star. So codomain. For every y belongs to codomain, if possible, f of x equal to y. Now we have to calculate x value. That x value must be belongs to domain. Then only it is onto. Otherwise, it is not onto. Okay, we'll check. What is f of x now? 1 by x equal to y, or 1 by y equal to x, or x equal to 1 by y. Is it belongs to n or not? No, it is not possible. Correct now? For real number y, 1 by real number may not be natural number. I will explain by giving one example. Since y equal to answer into, okay, it is there in r star. So what about x one? 1 by y, that is 1 by 2. It is not a natural number. What is the conclusion now? There is a number 2 in codomain which is not image of any element, which is not image of any element. Therefore, it is not on. Therefore, it is not on. What is the conclusion now? By replacing domain r star with n, the result also changes. Correct? Because before problem, both 1 and onto. By replacing domain r star with n, it is 1 but not onto. So the results are not same. Clear? Example 2. Show that n to n given by f of x equal to x plus 1 if x is odd, x minus 1 if x is even, is both 1 1 and on 2. So we have to prove it is both 1 1 and on 2. So diagrammatically it is easy to prove, but problematically we will prove. At the same time we will prove both the ways. So I will explain first diagrammatically, then we will follow the problem. First of all, the given function defined from natural number set to natural number set. It is defined like this: f of x equal to x plus 1 if x is odd, x minus 1 if x is even. Defined like this. Now we have to prove it is both 1 1 and on 2. So first I will explain by taking diagram n to n. It is a function defined from natural numbers to natural numbers. So what are natural numbers now? 1 2 3 4 5 7. Here are also natural numbers now. 1 2 3 4 5 6 7 8. First take 1. 1 means odd or even? Odd. So if 1 is odd, f of 1 plus 1, that is 2. 1 maps with 2. Next take 2. 2 is even. So if x is even, what is f of x now? X minus 2. X minus 1, that is 2 minus 1, 1. So 2 maps with 1. Next go for 3. Take x equal to 3. 3 is odd. If x is odd, what is f of x now? X plus 1, that is 3 plus 1, 4. 3 maps with 4. Next take x equal to 4. 4 is even. If x is even, what is f of x now? X minus 1, that is 4 minus 1, 3. So 4 maps with 3. So similarly 5 maps with 6, 6 maps with 5. Next 7 maps with 7 maps with 8, 8 maps with 7, like this. So clearly different elements having different images. So it is 1 1. So codomain equal to ring. It is on 2. Correct? So we will explain by taking diagram, but problematically how we have to do that is important. So graphically, diagrammatically, we can say it is both 1 1 and on 2, but I have to follow the process for solving this one. 1 1. What is 1 1? By taking x1 comma x2 belongs to domain, then we have to let us select if f of x1 equal to f of x2. Now we have to prove x1 equal to x2. Now that is the process now. So what is the selection? Selection is also very, very important. If possible, x1, x2. What are x1, x2? Natural numbers now. That may be even natural numbers are there, or natural numbers also there now. So those x1, x2, I'm setting like this now. If possible, x1 even, x2 odd. If possible, f of x1 equal to f of x2. F of x1 equal to x2. F of x1. What is x1? Even. If it is even, what will I have taken? X minus 1. That is x1 minus 1 equal to f of x2. What is x2? Odd. If x is odd, its value is x plus 1. That is x2 plus 1. So take it into one side. X1 minus x2 equal to 1 plus 1. X1 minus x2 equal to 2. Is it possible, ma? It is not possible because it is odd. Correct? X1 is okay. I'm taking x1 is even, x2 is odd. Even minus odd cannot be 2. Correct? Now, even minus odd cannot be 2. So it is not possible. It is not possible. Similarly, x odd, x1 odd, x2 even also not possible. Correct? These are not possible. So compulsory both x1, x2 must be either even or odd. Correct? So if I take one even, one odd, f of x1 cannot be equal to f of x2. If I take it, 1 x1 equal to f of x2, we got contradiction now. x1 minus x2 equal to 2. That is, even minus odd cannot be 2. Even number minus odd number cannot be 2. So that's why it is not possible. So we cannot take x1 even, x2 odd, or x2 even, sorry, x1 even, x2, x1 odd, x2 even. So both cases are not possible. So what is the possibility? Therefore, both x1 comma x2 are either even or odd. Correct? So we have to select, we have to prove in two cases now. First of all, I will take both are even. In second case, I will take both are odd. Okay. Case one. One only. For one only, I will prove like this. Case one. If x1 comma x2 are even natural numbers. So if f of x1 equal to f of x2. So what is f of x1? If x is even, what is f of x1? F of x minus 1. So here x1 minus 1. F of x2 minus 1. So minus 1 we cancel, we can prove x1 equal to x2. Okay, in this case f is 1 1. Next case 2. If x1 comma x2 are both I am selecting as odd numbers. No? If possible, only take if of case 1, case 2. If f of x1 equal to f of x2. What is x1, x2 here? x1, x2 are odd numbers. Now, if x is odd, what is f of x1? X plus 1. So f of x1 plus 1. F of x2 plus 1. So 1 get cancelled, we get x1 equal to x2. Therefore, f is 1. In both the cases, f is 1. Clearly, f is 1. So, okay, why these are not possible? No? One even, one odd cannot be possible. If I take like this, we got contradiction now. x1 minus x2 equal to 2 means even minus odd cannot be 2. Or similarly, if I take x1 odd, x2 even, then we get odd minus even. Odd minus even also cannot be 2. Na? That's why this is not possible. So only one possibility is there. Both may be even, both may be odd. Those cases I prove f is 1. Clear now? First part is over. Next, go for on to. On to. Here also, on to. If y belongs to n codomain, y belongs to codomain n. So y is, I'm taking even. Y is even. Okay. F of x is equal to y if possible. F of x equal to 1. What is f of x now? I'm taking x plus 1. That is f of x plus 1 equal to 1. X minus 1. Even case. X minus 1 equal to 1. X equal to y plus 1. Correct? In case 1 like this. In first case, I'm taking y is even. So x equal to y plus 1. It is also a natural number domain. It is there. For every even y, there exists x is equal to y plus 1. It is there in domain also f of x equal to y. Means for every y belongs to codomain, there exists x belongs to domain such that f of x equal to y. Therefore, f is on. F is on. Now go for second case. Case 2. Y belongs to not if for every y belongs to codomain. Here codomain is natural number set, na? So the natural number may be even or odd. Even case we proved already. Y is odd. I'm selecting y as odd. So if possible, f of x equal to 1. So what is f of x? I will take like this: x plus 1 equal to y. So x plus 1 equal to y, x equal to y minus 1, x equal to y minus 1. It is also a natural number. Sorry, domain. In both the cases, f is on. No need to write like this also. No? Simply, I will explain in other method also. See. 1, 2, 3, 4, 5, 6, 1. Here also 1, 2, 3, 4, 5, 6, 1. So 1 maps with 2, 2 maps with 1. 3 maps with 4, 4 maps with 5, 5 maps with 6, 6 maps with 5. Continuation is there. Observe. No? Observe. For y equal to 1, what is x value? Y plus 1. Correct? No? Y plus 1. If y is odd, x value must be y plus 1. See, for y is odd natural number. For y is odd natural number, there exists x equal to y plus 1 such that f of x equal to y only. Check it. There exists y x equal to y plus 1. F of x, that is f of y plus 1. So y plus 1, y plus 1 minus 1. That is y only, because f of x value is x minus 1. If x is odd, so we get like this. Okay. Next, for y is even natural number. For y is even natural number. So there exists x equal to even. If x is even, sorry, y is even, what is x mark? Y minus 1. 2 minus 1 is different. So there exists x equal to y minus 1 such that f of x equal to, what is f of x now? So two functions are there now, x plus 1 and x minus 1. So if you take x plus 1, that is y minus 1 plus 1, because y is even, then y minus 1 is odd now. So odd means you can take x minus 1. X cancel. Okay. What is the conclusion? For every, in both the cases, for every y belongs to codomain, there exists x belongs to domain such that f of x equal to 1. Therefore, f is on. So clearly we can say in both the cases, f is both 1, 1 and on. Two most important information are there. Now we will discuss those and we will stop today. Note. First one, n of a is equal to n of b and f a to b is 1, 1. F a to b is 1, 1 function. In class, f is on means a and b are having same number of elements. n of a equal to n of b. Both the sets having same number of elements. If the function is 1 1, then no need to check. It is already clearly it is onto. Reverse also possible now. That is n of a is equal to n of b and f a to b is onto function. Onto function. That implies f is 1 1. Have to remember now. It is obviously it is true. So both sets capital A and capital B have same number of elements. And it is 1 1, then it is clearly onto. If it is onto, then it is clearly okay. Thank you. Next class we'll discuss.